All right. So, Arson, do you want to give us an overview of how you want to run this?
Sure. So basically, first I want to go through the motivation of why we want to provide an implementation of IBufferWriter. And one of the mainline scenarios is today we provide a UTF-8 JSON writer which accepts this interface, which is a new interface that we shipped in 2.1 called IBufferWriter. And it's mainly meant for synchronous writing to an output buffer that the user basically provides us. We don't in the JSON writer support writing directly to an array or writing to a string. That is the primary thing I want to try to resolve. And since the UTF-8 writer is a ref struct, there's difficulty in terms of when do we dispose the memory, underlying memory, and we also cache the span as a field, which is why it's a ref struct. So we can't really accept streams and arrays directly and grow the buffer and underlying buffer ourselves. So the plan is to provide an implementation of IBufferWriter inbox that is array pullback, and the user manages the disposal of this type. So they knew of this type and pass it to the UTF-8 JSON writer. The only other type we have today in the shared framework that implements this interface is PipeWriter. So people who have PipeWriter today, they can just pass it directly to the UTF-8 JSON writer, and it will work as expected. And PipeWriter has a method called flush async. So it lets you do the asynchronous write to the actual output whenever you are done writing some data. That's the main motivation and problem we're trying to solve. The other thing is we shipped an interface with only a single implementation, and we generally try to avoid doing that. So as part of that, we want to make sure that we provide some implementation inbox for the users so that they can use or at least leverage sample implementation when they're trying to come up with their own. It also solidifies the contract a bit more, and I've got quite a few feedback around the lack of documentation on this interface. So this will help drive that as well, at least the discussion, and we can all be on the same page. So yeah, the API surface is there. Aside from this, implementing iDisposable and the interface itself, which is like advanced, get memory, get span. The key thing here is that it implements this copy method, which accepts a stream. So copy to and copy async, copy to and copy to async. This is the programming model, which is somebody instantiates an array buffer writer, they pass it to JSON writer. Once they're done synchronously writing to the JSON writer, they will call copy to async onto the stream that they want to actually write to.
After they write the whole buffer?
Right, or it's on them to track if they've written, let's say they're writing multiple megabytes or gigabytes of data, to track some threshold and periodically call copy to async.
Why would we not do it kind of automatically, basically create a wrapper for a stream that implements IBufferWriter?
Mainly because of the semantics of advance, which is you don't flush on advance.
Correct.
So the IBufferWriter interfaces only have advanced get memory get span. They don't have a concept of flush. So at what point do you write to the output buffer, output stream or output?
When you call flush on the wrapper, you would have to manually call it. This problem doesn't go away no matter what the API is. It's just here I kind of have to do that as well.
Yeah.
In addition, I have to worry about calling copy to, and I would want copy to be
No,
called.
copy to is your flush, basically.
Oh, really?
Yeah. Because you're writing to an underlying array pullback buffer.
Yeah.
So it's array back. You're writing to an array that keeps growing.
I see.
And once you're done writing, you copy to. You don't call.
And
flush.
when I call copy to twice, it doesn't copy the data twice into this. Okay, it basically it's not really copy to.
Yeah.
It's copy and delete what I already have.
Yeah.
I see. It's not very intuitive then.
Sure.
I would say.
Yeah. What would you propose instead?
I would have a wrapper for stream, as I said.
But now I don't support writing to an array directly. So now we need a wrapper for arrays.
Mm-hmm.
So copy to async doesn't call flush for you, right? It just calls copy to async on the stream. You still have to call flush manually yourself.
Flush on the stream itself.
I mean, if you're calling copy to async and passing to the stream, this class under the hood won't call flush for you on the corresponding stream, correct?
When it writes to the stream, I don't know what you mean by flush. Do we have Do you have to flush after the stream?
Well, no, we were talking about flush. We don't flush the stream for you. We will call copy to async on the stream for you when you call this method,
right.
But we won't call stream.flush or flush async for you.
Yes. We just do write async or you just write to the stream.
You think the flush you're referring to is the flush on the BufferWriter, right?
There is no flush on BufferWriter.
Then what flush did you just talk about? Because you mentioned that you flush for, copy
on the stream. So these two methods here, copy to and copy to async, take a stream.
Right.
And we call the corresponding copy to or copy to async on the stream, but we don't call flush for you on that stream.
Yeah, why would you, right?
Right.
Yeah.
But I think, so that is a good kind of additional point. But I think the biggest issue is nobody will know that this copy to can be called periodically and that it clears what already was written. It's so not how copy to methods work in the framework.
Right.
So why can't this wrap stream for the array case? Because memory stream takes an array, a byte array that it writes directly to.
Right. So now
So
so
you could write to a byte array, a backing byte array using memory stream if we had this just simple and
but
stream.
But it's not as performant. I mean, the performance hit would be quite significant.
Now you're making more hops.
So how is it related to this feature that Jeremy was working on? He was working on this.
He was working on BufferWriter.
Yeah, exactly. Yeah. How is that not a BufferWriter? It even says array BufferWriter.
So it is known as IBufferWriter, so it is a BufferWriter in some sense, yeah.
And writes to an array, which he was also doing.
Yeah.
Like,
I guess the key is that he doesn't write to a stream. So this copy API.
Well, and I'm arguing this API is not very intuitive for writing to a stream. Right. I think we should have two types. We should have the BufferWriter that Jeremy was working on, and I don't know, the whole design discussions got bogged into some difficulties and issues, and we never made progress. And then we should have a separate type, which is basically just a wrapper for stream that implements IBufferWriter.
So BufferWriter is not planned for 3 years. It's pushed out. And this is a scenario that needs to be resolved for UTF-8 writer. So I need to write to a stream and I need to write to an array. That's the primary motivation here, right? If BufferWriter was able to do that, we would be doing it. If, as far as I can tell, what the design was does not allow us to write directly to a stream, write directly to an array, which is why we need an API like this. And the second reason is we want to implement an interface of this type, of IBufferWriter, and we don't have such an interface. So this acts more as also as a general purpose API for anyone who wants to use IBufferWriter for their purposes.
So,
but also what you're suggesting is not the same thing, right?
Why not?
Because what you're suggesting is you have a stream that implements IBufferWriter. It's different from being able to take a BufferWriter and writing it to a stream. Because then you have the stream that implements IBufferWriter, but it still doesn't give you the ability to take an API that takes IBufferWriter and write it directly to a file stream that somebody gave you.
No, it is.
How?
You take the file stream that they gave you, you wrap it in this type that I just talked about, and then you pass it to the JSON writer.
Who calls flush?
Okay, but wrapping you don't mean a type you don't mean a type that extends stream and implements IBufferWriter. Then you're asking for some type that basically glues them together.
Either type that glues them together, or what you just said could be done too, because this is an interface. So it could be basically a BufferWriter stream. It would be called. It takes stream, it is a stream, and it implements this interface. So you can use it either to write through stream but the stream interface, I mean, the abstraction probably doesn't make a lot of sense, because it's just, if you call the stream APIs, you would be just calling a wrapper for no reason. It would probably be just the type that implements this interface, takes a stream, and
I think you want just a class that is, I don't know, stream BufferWriter, right? That just implements a BufferWriter and takes a stream, but that is not itself a stream.
Or we could, implement IBufferWriter on stream. Now that we have default implementations of interfaces. Anyway, that one is probably too risky, too complicated. But so
also, if you ever ask for Ubering this one, it will never work.
Yeah. But so, why did the BufferWriter discussions, the Jeremy feature, kind of stopped? Like what happened? Like because there were some, like I talked to him and there were some tricky things to decide, but they were like, well, we just have to make a decision and move on.
But it was mainly on timing and scheduling.
Well, why can you develop this type on time and not the other one?
Because this thing is a lot more lighter. And
yeah, why is it lighter? What does the other one do, and this one doesn't?
The other one is a whole feature-rich thing which has lots of APIs around reading primitives, supporting all IBufferWriter types, like a lot of it to do with real sequences, things like that.
This is just the byte sync.
Not real
right?
sequences, PipeWriter.
Right, this is just the byte sync.
Yeah.
Right?
So that's, I think that's another hardware issue.
Okay.
Whether we fund that or not, we should do it.
Okay.
This is more around, I want an array-backed IBufferWriter implementation. The copy to just help us to then add it onto here if to support streams. If let's say the copy to API doesn't exist, the user would just write to this, we'll give them the array we have written to, and they will handle the copy. So we could remove the copy to APIs, but then it just hurts usability for the stream case today. So sure, we can add stream wrappers or stream buffer writer and make things easier for the future.
But the stream wrapper, we need this type. Why would we not add it?
So I came with a proposal for one feature. You're saying we need more features. Okay. Yeah, so we should add more features.
You were basically just saying.
So
I misunderstood.
I'm not
just that
this
schedule.
an replacement of the stream buffer writer or the buffer writer itself. This is just one thing out of the three features.
But like this one would also requires you to buffer effectively before you actually write to the stream.
Right.
So if you have the other type that basically directly writes to the stream, why would you ever use this?
The JSON writer does not accept a stream-based thing, right? It would never write directly to a stream. It would always buffer. Especially since if you're doing async stuff, it would buffer to some underlying array to write asynchronously. And once you have reached some threshold, then it was periodically write to the stream. So the only time you can avoid copies is if you're accepting PipeWriter.
But isn't that just a limitation in the JSON writer? And you don't need a public API to create the bridge between having a buffer and having a stream. You just internally need to say, if the user gives me a stream, then they can write to it. They don't necessarily need this to bridge that gap.
No, but stream fundamentally requires buffering and copy.
Well,
unless
it's a memory stream and there is no buffer. It just writes directly.
No. It's an API issue. So stream.write takes a byte array. Correct? There's no other way to write anything. Takes a buffer.
Yeah, so it takes a
buffer. Well, the data needs to be in the buffer to be able to write to a stream. It is a buffer. The name buffer means there's some data that is being buffered. Somebody has to first write it to a buffer so you can then write it to a stream.
Right, but that can be a local buffer. It can be anything else. If you have this as well, then you have a third buffer.
No, there wouldn't be. There wouldn't be. If we implemented basically this wrapper for a stream, it would implement IBufferWriter, and it would be exactly equivalent to there is some buffer byte array. Yeah. Users writes to the buffer, and then the buffer periodically gets basically written to a stream. It would be literally the same.
This type and the stream wrapper has this behavior, which is there's a third buffer. This is the thing that's providing the buffer that we write in.
That is the buffer.
Well, right, but if you're wrapping a stream, then the stream is the buffer.
No,
you have the buffer. So right now you've got the JSON buffer, and then if you have this, you have another buffer, and then you have the stream.
No, JSON doesn't have buffer.
It's grabbing the buffer from your output sync. So for example, in the IBufferWriter case, we have the get span get memory. It's required. It gives you the buffer. So in the PipeWriter case, PipeWriter has buffers. It returns to you the buffer that you're going to write to. So you write directly to the output. In the stream case, or in this case, they would allocate a buffer from array pool, give that to you. That's the one buffer. And then we write into it, we give that to the stream.
Yeah, if you think about the interaction, right, I just looked at IBufferWriter again because I forgot what the interface looks like. IBufferWriter basically just gives you a span. You say get span for a size, I believe, right?
Yes.
And then effectively, so in that sense, IBufferWriter provides you access to the underlying buffer you're supposed to write to, right? And that just disposes it as a span. Right. So let's say you create this type that Christopher was proposing, like a stream buffer writer, right? Which basically takes a stream and implements IBufferWriter. Yeah. That type, effectively in its implementation, has to have an array that grows. Because the thing is, if you call getSpan, which is your interface to the people that take IBufferWriter, you have to give it something to write to, right? When this guy is done, then basically what you do is you call stream.writeAsync or whatever, passing in that buffer, right? So like your implementation has to have a buffer somewhere, right? So what he's proposing is basically saying instead of having two, just have one, which is this guy, and then just have a convenience method that gives you the ability to just say, oh, in order to write to a stream, and as opposed to you doing it, you just call copy.
By the way, I have an idea how to solve your problem of schedule and shipping one feature or another.
Just ignore
Why
the
don't
schedule.
we add flash async to this type and make it virtual?
Okay.
And basically, you ship this type. If I want to write to a stream, I inherit from it, and inside flash async, I write the buffer into the stream.
If this type becomes virtual, then calls to get span stuff to slow down, won't they?
There's only one method virtual.
I see.
It's flash async. And basically, so I inherit from this type because you cannot. Maybe in the future we ship the inherited types, but for now I inherit from this type. I add a field stream, override flash async inside flash async.
So,
I grab this memory and write it to the stream.
There's a spectrum. One thing the user can do today is implement IBufferWriter. The other spectrum is they have this type and they don't have to do any implementation out of the box. You're suggesting they have to write the flash async.
Mm-hmm.
You say, will we still provide an inbox implementation of flash async? It's just a virtual method, meaning it's not, there's going to be implementation already. The default implementation. Will we provide such an implementation? Or will it just be purely abstract?
Maybe it's not a good idea. I
So,
don't know. Because it depends who would call the flash async.
right.
So I don't understand the flash async thing. So why do we need the API at all?
Which, the flash async?
Yeah, why don't you just inherit from array buffer, right? I call it a day.
Well,
Inherit, it's a regular, or sealed, it should be a sealed class.
Well, but let's say we don't see it, right? Let's say in Christoph's case, you just inherit some array buffer writer called stream buffer writer. Like, why do you need a virtual flash async on the base? What does it buy you?
maybe maybe you're right, because I was imagining that it would be integrated with the JSON writer, so I don't have to worry about the flash async, but I have to call it anyway.
Well, I mean, if you really cared, I mean, what I would suggest instead of doing that, I would just say implement async disposable, and make async disposable call flash async.
No, because then you want to flash periodically. You don't want to flash only when you dispose.
Sure, but that can be handled by whoever handles it, right? Like would you change the contract of the array buffer writer to say the consumer has to call periodically flash async? Because for the array case, why would you ever do that?
So
I'm not sure. I'm just saying that like async disposable doesn't solve the problem.
So these are just two convenience methods, right? The copy to and copy to async. If we didn't have them, it would be like 1 or 2 lines of code to do it yourself.
Yeah.
Right.
Yeah. So I don't feel strongly we can remove the copy to async if there's a team that can support a stream-based implementation. If you look at the sample, if you scroll down to the sample, that might help at least showcase the usage. So the first one is a straightforward synchronous write to a file. And if you see where the usage is at the last line, output.copy to file stream. So the file stream is not used anywhere else inside this writing, in the code where you're writing the JSON writer, using the JSON writer. So it could just be that the user.
Yeah, they would have to manually just basically say file stream dot write, output or whatever,
right.
The current buffer, and then clear and then move on. Okay, I would just remove those stream helpers. One additional kind of architectural question. So this thing uses the buffer pool to allocate buffers. How do I return the things to the buffer pool?
It's disposable, so once you get rid of the array buffer writer.
So I basically have to hold to the instance of the writer.
So as you see, so we're using the array buffer writer. Once you out of scope, that's when it gets returned. Or on whenever you resize the underlying buffer gets returned. I mean, this is somewhat based on the implementation prototypes we had in Perfect Lab.
Yeah, this is, I'm not sure if it's the best design.
Okay.
Because basically, let's say I wrote to an array. Now I want to send it over the network. I kind of need to hold to this buffer writer till the network call returns. Otherwise, I cannot dispose the buffer before I know that the data was sent.
Sure.
So that's a bit of an issue. I
But
don't know.
isn't
Maybe.
that how most arrays and streams and everything else work? Even if you were to do it manually?
No, if I did it manually, I would just hold to the instance of the array and then return it to the pool when it comes back. Now I have to hold to the instance of both the array and the writer. Because the only way to return the array to the pool is to have the writer.
Right, but that's not going to be expensive to do.
I don't know. I mean, it's not that it's expensive. It's now I have to potentially have two different fields in my thing that, does the network interaction.
Why would you hold on to the array at all?
Yeah, because the buffer is holding on to it, and so as long as you have the writer, you have the array. And I didn't think we exposed the array anyways. We just exposed span and memory. So you would never be able to hold on to the array yourself.
So by the way, around removing copy to, when would we reset the array buffer?
There's some feedback.
Hello.
No, it was your voice.
Yeah, I know. Is it fine now? Okay.
Yeah.
When would we clear the underlying array of data? How do we know that the user has it periodically flushed so that we start writing from the beginning again? That's one of the primary reasons to have the copy to method rather than relying on the user to write to the stream themselves. That we maintain state in the array IBufferWriter to know where we have to write to. So if you remove that, then the user has to do more work, not just write to the stream. So they have to reset the array IBufferWriter to the beginning.
So, on a bit of a related note, but separate question. So our JSON writer does not support writing to structs implementing this interface without boxing them, correct? We remove this feature.
Yes. And if you were to use, if you have a struct-based implementation, then since we box it, you will not see the caller will not see it because it will be copied by value. And if you look at the async sample, this is what I had in mind, which is you keep writing, as you're writing an array of elements, you write some JSON, and you track how much you've written. And once you pass some sync write threshold, I'd say like 1,000,000 bytes, then you do the copy to async, and then you continue writing your array. That's how you would support writing large JSON, large files with JSON writer today using this type. So I'm not too sure how great it would be if we don't remove the copy to methods.
Yeah, so this is actually not array buffer writer. Since I don't have access to it, so related to portability, we don't have in net standard APIs to write memory to stream.
Sure. Which is why I have these copy to methods.
Well, for memory, you just have to do memory.getSpan and then write the span of the stream.
No, we don't have that either for portability. So
oh, you mean in standard?
Yeah, that's what it is. So another reason why we may want to have the copy to methods.
Wait, we're not exposing the span overloads in 2.1?
In NetStandard 2.1, yes, but not 2.1.
Right, but then is the JSON writer going to be in 2.0? I thought that was also going to be 2.1.
The JSON writer is available in Inbox Netcode 3.0 as a source package in standard NetStandard 2.0.
Oh, as a source package for 2.0.
Yeah.
So this problem occurs today in things like code setup or any areas where you write to a stream, and they need to use the JSON writer. So as part of at least a stopgap feature to make sure that works and we can remove upstream dependencies easily, we need a type like this. We definitely need a type array IBufferWriter which implements IBufferWriter. Now whether we need copy to or not, that's arguable, but I definitely see value in it.
Why don't we just give people access to the array that you hold? Because you are afraid that they will mess up the pooling.
Yeah. And again, it's like somebody can implement IBufferWriter themselves today and pass that to us. That was never the concern. The concern was making sure that we have some implementation inbox, so users don't have to go out of the way. Every user doesn't have to go out of the way. So the whole point of this API is to make it convenient and to drive it based on the scenario that I need to write to a stream. So the copy to method inherently supports that, so that the user has to do no work. They implement this type and it works.
Also remember we did this on memory stream and it was considered a mistake.
What
Oh,
did you
giving
do?
the underlying array.
Yes, we basically changed the behavior so that if you didn't pass in the array, you don't get it out ever. Because otherwise you fuck up there. Because as soon as the guy grows, you're screwed. Right? Because then you're holding on to the wrong array. Like it basically breaks encapsulation in general when you do that, and then you have very subtle bugs that are hard to pinpoint.
So one thing we could do is just basically change the behavior of the copy2 methods and say you cannot, they don't clear. I think this is basically the unintuitive part.
Well, but no matter what, right? Somebody has to remember to periodically do that.
No, you do it at the end.
You
No,
buffer
because you cannot, you need to clear the underlying buffer if you're writing multiple gigs of data.
Yeah.
Yeah, this type is not for writing multiple gigs of data.
Then how do you write the multiple gigs of data?
You implement a stream basically wrapper.
I think so. Thinking about it, I think what we probably need is like the type Christoph suggests, and the value that this type adds is yes. So you could imagine that this type is implemented by just having the array buffer writer as a field, and then it just delegates the IBufferWriter to its underlying thing, and then also periodically calls flush.
So I have both types: a stream buffer writer and an array buffer writer.
Because the stream buffer writer, the value that it really adds, in my opinion, is the periodically sending the data down the wire.
Right.
And knowing when that's a good terminology.
So stream buffer writer would have the copy2 method.
Well, there's a fundamental problem
Maybe
with
you
the
don't have
periodically
a
send data over the wire.
Why?
Because IBufferWriter is a synchronous interface.
Right.
To send buffer over the wire, you need an async call. JSON writer does not have a single async call.
Yeah, so that's why this type has the async method. And the stream writer would have the same thing, would have the async method.
Yeah, and then JSON writer would not automatically call this async method periodically for you.
Yeah.
But that's what Dino was saying, that the periodically the stream writer would call something for you. And it's kind of true if somebody directly uses this wrapper type, but if somebody just passes the IBufferWriter to JSON writer, it won't happen.
Right. So basically what you're saying, no matter what, there's a new API that is asynchronous that one person has to call, and we can decide where that lives effectively, right?
I mean, it seems like, it would be useful to have async buffer writer, and JSON writer takes it, and then JSON writer has a flash method, flash async, and
you can't
call
have
it
a flash async method because it's a ref struct.
What?
How can you have a flash async method when it's a ref struct?
What's abstract?
Ref struct.
Oh.
UTF-8 JSON writer is a ref struct.
Yeah, you can't have async methods and ref structs, right?
That's the primary reason why. Even if you were to extend the interface, one of the options is that we probably still want to consider doing is extend the IBufferWriter interface as an async buffer writer, which has the flash async method, which PipeWriter could even consider implementing because inherently PipeWriter already implements because they have a flash async method in PipeWriter. But the JSON writer would never take it.
So how would this work today? So today you would say, let's say I have to write, I don't know, 5 gigabytes of JSON for my web service, right? Yeah. So the idea would be that the method that does that somehow has to batch. Somehow has to batch and then unwind the stack effectively, keeping on to the JSON writer state. Do the flush async and then again new up a JSON writer and then keep going.
So if you look at this sample below, here's the write gigabytes of data. That is the method, and the thing that's writing is that thing. So you get the state, you reinstantiate a new JSON writer, you write some threshold of payload, like let's say 1 million bytes, and then our method above periodically calls async.
It is unfortunate that the caller has to.
That's the programming model we have today. It's similar to the programming model for reader, and writer has the same thing. And I see value in the copy2 methods, especially for this scenario and what we have today.
So what do they actually do? Like besides just doing the obvious, which is write, taking an array and the length and offset.
What would they have to do in the copy methods?
Yeah, if you don't,
they have to clear the underlying array or buffer writer. By which I mean send the cursor back to 0 and clear some data, especially.
Because it's not only copy2, it's basically copy and consume.
Right.
It's kind of copy and clear.
Exactly.
It's more like a move to, right?
Yeah. So you can look at the sample implementation. Actually, I have a link to it if that helps.
Yeah. Is that the?
Scroll up a bit. Oh, that's not it. Keep going. Oh, sorry, at the bottom.
If you scroll up, you can scroll down.
Yeah, scroll down. There. Capital version. You can see exactly what copy 2 is doing. As the constructor,
Yeah. Clear helper and clear helper is, I think, this guy, yeah.
So additional. So
here's the data you've written and resets the cursor back to 0.
So I think we have scenarios. I still feel this API is not what we ultimately want. To give you another example of scenario that I imagine people would want is never resize the buffer. When you're about to resize, call me so I can copy to and move on.
So IBufferWriter exists, and you can implement a fixed size IBufferWriter very trivially. So for custom scenarios, we have the implement of IBufferWriter. I mean, we have the interface IBufferWriter. So there's nothing stopping that scenario. And the question is, do we provide something that's easy for everyone to do to onboard onto the JSON writer?
How is that provided by this type?
It's not provided by this type.
Oh,
okay. It's trivial to implement a non-growing fixed size BufferWriter implementation that's backed by a fixed size array. So, and I don't know how common that scenario is. So that's the reason why I'm focusing on providing this type, which is so that anyone who doesn't know anything, just wants to write data, they are able to do so using the writer.
But then you're still back to square one, right? Because like it's the same problem that you outlined before, right? If you say you never grow, at the time you grow, you're in a synchronous context. So how do you do anything asynchronous like writing data to a wire at that point? So fucked again. So I think if you want to have a centralized thing, you need to rely on somebody in an asynchronous context pinging you periodically to say do it. So somebody has to write this outer loop that is asynchronous.
But also with fixed size array, what happens if you have data that was unexpected? You throw.
Yeah.
If you have a fixed size buffer and you start writing more than what is required, you throw.
Oh, he's saying there's a callback, and the callback has to do whatever it takes to make room.
Yeah.
Sure.
Well, if you're doing it with a stream, then the stream takes care of the buffering and the flushing as needed when you fill the buffer.
But so in his case, if it's a fixed size buffer, let's say it's 4K, you may not have done writing your single token.
Yeah.
So at what point do you flush?
Yeah.
You can't flush periodically while you're in the middle of writing.
Yeah, the buffer never you never can continue partial token writes. You can only continue like basically he could call and say, hey, I don't have enough space to write the next token. He cannot ever basically call you and say, I wrote part of the token. Can you give me a larger buffer so I can write the other part?
Well, I mean, if this interface or if this struct took a fixed size buffer and had a flush method, then when the buffer was filled, you would call flush and continue writing whatever rest out of the buffer that the user gave you to copy from until that was done. And then you would throw.
Who would call the flush method?
You would have to when the fixed size buffer was full, because the user gives you a buffer that you're copying from, and it's the same way stream works. It's you're not you have all the data. You just have to send it in small packets to get it all processed.
Well, he doesn't have all the data. That's sometimes the case. Because basically, have all the data means there is some buffer that has the data. Well, he's actually writing to the buffer, and if the buffer is too small, he cannot have all the data.
What happens if you have a token that is too large to fit in any .NET allocatable buffer?
Then,
right.
the whole feature doesn't work.
Yeah. Like if you're writing more than 2 GB of JSON string, single string that's more than 2 GB, yeah, it's not gonna work.
But that seems like something that realistically should work. And normally you do that by buffering and then writing small packets of the buffer.
Right. To support that scenario, the user would have to write their own custom implementation, because I have not run into that issue or that ask where someone is looking to write more than 1 gig of single token.
You could imagine it's not necessarily always a case of the user has a large token. It could also be a case of the user's app in general has high memory overhead, and they're wanting to write maybe like 10K of data, but for whatever reason their app says I can't allocate that much data, and now they're SOL because.
Well, but I think what he's saying is what you said, the scenario is valid and it can be implemented, but it's a more complicated feature. He's saying, can we have something simple for the scenarios that are very common today? And I think it's close. I still worry about the copy to async.
Yeah.
Basically doing more than what copy to async methods in the framework do.
Right.
I think it's very unintuitive. On the other hand, if we remove them, then because this type doesn't give me access to an array, I cannot actually use it in a portable library. And
but are you objecting more to the name? Like, let's say we rename the method to make it clear that it actually does clear the buffer.
Sure.
Like, does that address the problem?
Yeah, possibly.
I mean, like, move to async or something like this seems.
Another thing we could do is basically keep them as copy to async, and the user has to manually, after calling this method, clear.
The problem is that they don't have we provide a clear method that does the clearing. So we have a clear method today that just resets the index. So yeah, actually, we do have a clear method.
So actually, if this copy to async always copied the whole buffer,
Oh, no, you don't. Oh, yeah, sorry.
you would copy to async and then clear.
Or does
Copy
clear
to
method
async.
differ from clear helper?
It doesn't.
Okay.
Yeah. So we have a clear method. That does. So yeah, we could do that. So the copy, like the user has to first copy, then clear.
And
It's just more boilerplate that they have to remember to do.
Yeah, it seems like that's almost something at that point, you may want to provide it with just the one method, right? Because I mean, why would you ever do copy and not do clear?
Right.
well, I think it just it makes transparent what's happening.
Sure, but now you have because of this is you can look at code that looks reasonable, but you now leak memory like crazy because you forgot the clear method.
Yeah.
Well, then your code wouldn't work. You have a bug. It really wouldn't work properly, so I don't know.
Yeah, because you repeat the data every single time you go up to it. I think fair enough.
So we could. I mean, if we have a great name for the method, sure, it could be Hamper, but I don't.
It's called move to.
But that's not what it does.
It moves the data.
It's doing a memory move, basically.
Yeah, it takes the memory from here.
Oh, you mean? I see. Maybe. Still, how do I know how much data is written to the buffer? Is there a property?
So there's a. Where is it? No, I don't expose it. So there is no way to know how much you've written.
Is there a way to, because basically for the scenario of I don't want to ever resize or I want to minimize resizing, if I could basically check some properties like how much free space there still is.
Sure. So we have bytes written and bytes committed. I keep forgetting. I'm looking at the data surface, but we have bytes written, bytes committed, and we have the output as memory output as spec. So you get the slice of data that you've written, that actually what contains the data, and you also have how much you've written and how much you've committed.
I think if you want to implement a policy, you want to know how many bytes you have, right? So you can make smart decisions about counting the bytes yourself.
So if you go back to the API service, I just want to make sure that you're on the same page.
Quite literally, we are. Because looking at the same screen.
I mean, you might use, this is what I did. I subtracted the two, and I'm like, okay, 90% of allocation, time to call, copy to, or manually do it by getting the bytes or the span or whatever.
I see, because you sort of the ratio between the two.
But the full size of the buffer, where is it?
Not the full size. Why do you need the full size?
Because I want to know. Oh, I just need to know how much free space there is. That's what I need to know. I don't need to know the other things. I just need to know free space.
Why?
Because I'm about to write an int, and I.
Yeah, well, that's what I was referring to. I thought you could subtract the two. You can't to get the free.
What are you subtracting, Steve?
Well, I mean, okay, you have an example usage down below, and you have this threshold, right?
Yeah.
But I mean, the threshold could be like, hey, if I have, if there's only 10% of my buffer left, I'm going to stop writing to it.
How do I know that I have only 10%?
That's what. Yeah, exactly.
Well, isn't that just bytes committed minus bytes written?
No, because bytes.
Well, that's what I thought, but.
Because bytes committed should be.
No, I need to know the full size of the buffer.
He's asking for the size of the underlying buffer that we're writing into.
Right, because you could have committed less bytes than have filled the buffer.
Yeah, So I thought that meant something else actually. So
what is bytes committed then? I'm confused now.
So bytes committed.
You need another one called bytes allocated or something like that.
Right.
So, but what is bytes committed?
Bytes committed is how much you're copied when you do copy async. Every time you copy async, it's remembering how much you've written. So how much?
So it's the total number
Yeah.
of bytes versus bytes written is just basically in the current.
Yeah, which is why one is a long, one's an int,
I see.
because the byte written can never grow more than an int. But
Yeah,
byte committed
that
can
makes
be-
sense now.
So I think it may be worth exposing
Yes.
Yeah.
exposing a property called capacity. Basically, capacity is the size of the buffer, and then I can just subtract from capacity
Bytes
bytes.
written.
Well,
I think bytes written should probably be called length or count like everything else if we have capacity.
Yeah, capacity should be the size of the buffer. Length is what you're
Well,
currently in the buffer.
No, that's
You
not.
also need the local count, not the
That's
total
stream.
count, the current
Stream
count.
works. The
Stream
writer works.
list.
Length
Just
is,
stack.
Oh, okay.
length is the size of the things you have in the buffer, and then capacity is the size that the buffer is.
So I get capacity,
Yeah.
but now the reason why I want to keep the bytes written is the parity between bytes committed and bytes written.
No, I think that makes sense. It's just that I think length should be the current buffer window, right? Basically, how
Okay.
many have you have, and then maybe you have total bytes written, which is basically long,
Fair.
which is basically like everything you have ever have done, right?
I'm fine with that.
Which seems reasonable.
And are we fine with one of them being in 64, one being in 32?
Yeah, I mean, as you said, right? The one can never be more than 2 gigs,
Yeah.
and
Yeah.
for almost everything you would do with that number, you probably want an int at the end of the day, anyways,
Right,
because you pass it to span or whatever, right?
but I wonder whether the bytes committed. You have even a question: do we need this? When would I use it?
If you want to know how much you bring to the stream. Otherwise, the user would track it themselves, especially if they want to move some.
I see. Yes, it's actually important if I want to write to a stream and know how much.
Essentially, a lot of my motivation is to avoid boilerplate code that the user have to write.
Yes.
So provide features, like otherwise user has to
Yeah.
create their own counter. And remember,
Yeah, like I did.
so a lot of this is driven from my feedback from you. So anyway.
Yeah, contrary to popular belief, we actually do take feedback into consideration. So there's one question. So one was, Ivan is asking, why don't you expose read-only sequence of byte from the array buffer writer? That way I can copy it to wherever I want that is not a stream, for example.
Read-only sequence of byte. Where are we getting the read-only sequence from?
I mean, you're not really a sequence, right? You're always a singular
It's
buffer, right?
single contiguous memory.
Yeah.
That we write. If you have, yeah, exactly.
But do we have a conversion from memory to read-only sequence?
Yeah, we have an API that takes memory.
Okay.
Yeah, I think the read-only sequence of byte would basically be an IBufferWriter that is backed by an IPipe writer, right? Effectively,
Yeah, but even then, I don't know where read-only sequence will come into play.
Well, like logically, you are a connected buffer, right? I guess in this case, you wouldn't buffer, right? You would just write it out as soon as you can. Yeah, I think the logical problem is that we don't want to keep everything in memory, right? Which is what the read-only sequence would indicate.
So, aside from the feedback we have gotten so far, one thing that is also to consider, aside from stream writer and buffer writer, which are features that we want to add, is sequence-based writer, which is instead of allocating and resizing every time, you append to in memory and you keep growing it using memory pool. I tried that approach, and I mean we could consider adding another implementation of this interface, which is maybe memory buffer writer or things like that. But it made things like get span and things slower because you have to always round trip through memory. But you avoid the constant resizing and growing the underlying buffer because you keep appending fixed size buffers. So there's a trade-off to be made there.
Separate feature.
Yeah, exactly.
One thing about the API specifics.
Yeah.
Why would the IBufferWriter APIs not be implemented explicitly?
What is the benefit of doing this?
That they are hidden because they kind of, I don't know, like a consumer of this type probably should not call these methods directly.
Okay.
Because they are kind of tricky to call, like
Agreed.
what do I pass as a hint and whatnot. And
Yes. That's fair. I don't have.
So what's the proposal?
I'm not sure about that, but one thing I wanted to run through is the three methods that are the IBufferWriter implementations. Should they be implemented explicitly?
Oh, I see what you're saying.
How are they hidden, by the way?
You just implement them explicitly.
Yeah.
No, but why? How are they hidden?
They are not.
Oh, they don't. Okay, they don't show up on
just-
array buffer itself.
Yeah.
Yeah.
You have to cast that buffer, right?
Yeah.
I think That's probably fair because you would never expect somebody to new up an array buffer writer and call IBufferWriter methods ever, right?
I mean, maybe you
you could.
You could, but then they just need to cast to IBufferWriter, right?
If you're doing if this is your interface to write to an array pool, some custom data and flush to stream, that's nothing to do with JSON writing. Something else you're doing. You want to use these APIs. So this is the value in it. I just don't have a scenario. Is there a breaking change to go from explicit interface implementation to non-explicit?
I don't know, but I don't think so. But everything is breaking change.
Right.
We just need to look up in the document whether this one is really something that we care about.
So I mean, I can come up with scenarios where users are using this type as a standalone type, which is nothing related to our underlying writer that accepts an IBufferWriter, and then they would use these APIs, right? Like I just want to write some ints to a stream. I would use advanced and get span and stuff to just write to the data.
What if I already have an array and I want to write to it?
Question. Your constructor using sequence. Not using sequence. Actually, that's true. We could provide an overload. Constructor overload that accepts the array.
It complicates the situation a bit because what happens if then you need to resize?
Right.
But it may be a real scenario.
So again, for fixed size buffers, there's nothing stopping you from creating an implementation of IBufferWriter. You pass that in. So I want to avoid the corner cases and focus on the mainline standards that we actually have. I agree that there's many things that are not supported today. So for writing to a fixed size buffer, like yes, you have an array and you need to pass to a JSON writer, and you don't care about it growing.
Yeah. So if this is okay. So and one last thing maybe because I need to run soon.
Yeah.
Could we just implement IBufferWriter on list of T?
Because it manages the growing for you already.
Because basically, if we implement the three IBufferWriter methods explicitly, the rest of the APIs are pretty much, what list of T would have, and nobody would even blink. But I don't know. Maybe it's taking it too far. Anyway, I need to run.
I also think on list of T, the get span method that takes a size hint that doesn't return the underlying span but resizes it, but returns the remaining capacity and potentially resizes the underlying capacity to match that is really confusing for something like list of T.
That's true.
Well,
and I think those APIs in particular are confusing in general, but on list of T would be even more so.
Especially then it wouldn't be particle ring.
Yeah. So to target some of the specific questions I had, are you fine with the name, the type name, as being array buffer writer?
Given that it only writes to an underlying array, I think that's probably fine.
Do we need to say the name bool in there? Or do we need to say binary because it implements IBufferWriter by even the bufferWriter is generic?
Yeah, it seems like, it's a byte. It's, so array by itself doesn't seem right to me. But.
Yeah, and I don't think binary makes sense as well because most of the other places where we use binary, it supports writing all the primitive types of data rather than just byte.
Right. Okay. Why did you brought out there? Emo, do you have any suggestions on the name? Are you good with the name?
Of which part?
Array bufferWriter as a type name.
I think array bufferWriter is fine. I think
And I don't like memory bufferWriter because that would, to me, that would imply it also supports span and or memory as the backing data.
You are baking it by an array, right? In the same way that if you were to do the type Crystal suggests, you would call it stream bufferWriter, which is basically backing it by a stream. Right? That seems. The fact that it's also holding on to an array bufferWriter is just, as Christoph said, the way streams work in general, that somebody has to buffer.
Right.
So that seems, not fine, but that's just, I think the way the code crumbles.
Do we need to support custom array pools that the user passes in rather than using the shared array pool?
We don't have an array pool interface, though. Not a public one, I didn't think.
You could implement your own custom array pool. array pool of TIB.
Oh, it's on system.
Then you'd have to create another interface or something for that, right?
We have system buffers array pool.
Right. No, it would just be basically a constructor overload in this case, which accepts the pool. Right now we use the shared pool. If the user has a custom pool that they want us to use, we just add a constructor overload. This is something we can defer later as soon as there's an ask. So there's no need for it today. I would want to just throw that out there.
Yeah, I would think allowing a custom array pool would make sense, especially for performance-oriented scenarios where that may be.
Okay, so I don't know if you try it preemptively. I would rather wait. Someone asked, but I don't think there's nothing stopping us from adding it. It will just be a constructor overload.
Yeah, the only downside to not exposing it is that anyone who wanted that scenario would have to wait till net standard to X before they could use it.
So I don't know if you were able, if you recorded that, which is bytes written is now called length, and bytes committed is total bytes written.
So that's just the conversation I have with Nick Craver on this.
Yeah.
So basically what I recorded was we should rename bytes committed to total bytes written to length, and we should add capacity. The problem that Nick is pointing out is that length is somewhat confusing because if you look at the other types that we have, it's list of T or string builder, they don't really represent sliding windows, right? So length is always everything you have written, right? Capacity is just how big can the buffer be, right? So in that sense, I think capacity is fine. There's just this problem of, total bytes written versus length. Maybe we should just have total bytes written and bytes written. Maybe that's good enough. And then we just say bytes written is within the current incarnation until you call flush, and then total bytes written is effectively.
If you're doing that, then I don't know why couldn't we not keep bytes committed the way it is? Because bytes committed
my strongest argument is that from all the 4 people in the room, and including Steve on the call, nobody knew what it meant.
Yeah, I think
I think capacity is the easiest way to think about the total size, and then bytes committed versus bytes written. I think it's unclear. Like, unless you look at the return types, it's not clear what the relationship is, right?
In this particular case, the most important information, including the information that would be useful for things like get span, seems like it would be bytes available rather than the number of bytes that we've consumed out of the span that we have so far. So maybe we should consider exposing capacity, bytes available, because from that, you can infer the other, but bytes available is not only used internally a number of places, but it would be used externally for things like, can I fit it into what's remaining?
Right.
And then total bytes written indicating how many things we've actually pushed through the copy to.
Yes. So bytes available basically gives you the hint whether or not get span would succeed without growing.
Yeah.
Yeah, Graver suggested bytes pending, but I think my problem with bytes pending is that it kind of depends on your perspective, right? So because basically pending for what? So pending to be flushed, right? But that's not necessarily clear depending on how you see that. I think honestly, like bytes written and total bytes written might be enough, because if you see both of them, you're like, wow, there's only really one interpretation.
Well, yeah, but then you don't have a way of saying how much space do I still have to write before I need to grow or flush.
No, that's capacity minus bytes written.
But then you have no way of determining how many total bytes you've written.
No, you have total bytes.
He's saying
total bytes written,
bytes written,
and capacity.
I think the bytes available one is more useful than the bytes written one. I think most people will.
So we need the bytes written one for the scenario, because bytes written is what you use for.
Yeah, I think most people will end up having bytes available, because rather than anytime they want to say, do I need to flush, they'll want to know how many bytes they have available, so they know, do I have enough space to do this, or do I need to flush now?
Actually, what would be kind of cool is if somebody's asking for memory, you can do an auto flush if you don't have enough room.
Yeah, but then this problem is now if a sync call that has to do an asynchronous operation.
Yeah.
Right. And then we have to remember the stream that you're writing to rather than it being passed in
Right. So, but I think honestly, I'm not opposed to also exposing bytes available. I mean,
Yeah.
Sure.
like you can just
yeah.
document this. It's literally just this one minus this one,
Yeah.
and then you just write your code accordingly, right?
Right.
I mean,
and I think that'd be fine if we exposed both. But if we exposed one, I would be in favor of bytes available because I think that's what most people will end up needing.
So here's my question:
More commonly.
the reason why you use had bytes written is you keep writing until you reach some threshold. Let's say 1,000,000 bytes. You don't flush, or you don't copy to the stream. So it's based on how much you've written that you then decide, okay, now I should start writing to the stream. I've written enough data.
I think in performance-oriented scenarios, people would rather flush periodically and prevent resizing the underlying array,
Okay.
Rather than just saying, I'm going to keep doing this.
Okay. That's a fair point. So
and like the underlying stream has a fixed size buffer as well, and it's not going to keep growing.
Right.
So, and the default for that's like 81K.
Okay.
And so someone might want to say, I'm going to make this array buffer 81K as well,
Right.
and when that fills, I'm going to flush, because I don't want to have 1,000,000 bytes allocated on the GC.
Right. Okay.
well, the only reason why you still want to have it is because you may not be able to do that in all cases, right?
Right. You might not be able to in all cases, but I think
Because your check might happen after somebody wrote data that is bigger than what your initial
Right.
buffer size was, right? So in that sense, you would just grow to the maximum you need for whatever your atomic, units are,
Right.
right? Basically, in JSON, it would probably be the tokens or the J objects that you're batching.
Yeah.
But I think I think these properties would make sense. I think if you see them all together, like total bytes written, bytes available, I think people will be able to reason about what they do. Versus
Right.
these ones are a bit more in the
That's right.
And then the other one we said we wanted to implement the IBufferWriter methods as it's explicitly, right?
Yeah, I don't know if I buy that. Mainly because Christop's point is around hiding it and remove the complexity because users will not usually call advanced get
Yes.
get span. That's true today for if you have a writer that you write it to. But if you're using this type as a standalone, you would call this APIs.
So how would you use it? Like, why would you use this as a standalone thing? Like, what code would you write? Isn't the vast majority of use cases, well, the exclusive amount of use cases, you pass this to an API that does the actual
Right.
bundling? Because
Yeah.
IBufferWriter is not great, right? Like,
Right.
it's basically like, well, give me a span to write to,
Right.
and then I have to do all the heavy lifting myself.
Yeah.
Versus I would probably want to new up something else that allows me to write the things I actually want to write, either JSON or primitives or whatever, right?
One of the benefits of this could be that you could try. I mean, one of the standards was length prefix, where you advance by some amount, so you can fill it later with the amount of data you've written.
Okay. Well, how common is that?
Not very, but I don't even know how. I have to reason about how it would actually work end to end. I don't know if the thing will support it, so I'm fine with making it explicit. But it was an ask to support length prefix rights, and I believe this would work for it because you could advance up front. But I'm not 100% sure because I haven't tried it.
Where did you determine the initial capacity, 256 from?
It was mainly because based on my scenario and arbitrary performance testing, which was if you have a small JSON code you want to write a few fields, it fits into 56. So that's what I decided at. There's no other real reason. I didn't want to allocate or write from the pool like 1K when 1K wasn't necessary or 4K when 4K wasn't necessary.
But if it's the array pool, aren't we probably going to have a number of 4K buffers in there already? Because that's a common buffer limit used by like stream and other stuff.
So the question is, do we have any default? And then the question is, do we have 4K or 250 or whatever else?
I think it could probably be in internal implementation detail what that limit is.
Yeah.
Like instead of setting it to 256 here,
Yeah.
set it to -1 or
Sure.
something, and that way we can internally tweak it, and people
And change it.
Yeah, can change it as needed, but we don't have to worry about someone compiled on against net standard 2.1
Right.
and that was 256.
Yeah.
We've moved forward and we've since determined that it should be 4096,
Right.
and they don't get that benefit.
Gotcha. So everyone's fine with keeping the initial like default as in I don't care what the size is, do whatever you want, and then that's where you indicate with -1. Okay,
Yeah.
that's fine.
Yeah, so the one thought that Nick has, which is an interesting one, is so if we rethink the API strippers of the type as not as a buffer, but as effectively the stage for the things you need to write,
Yeah.
then you would express your API calls always not in terms of what I have not written yet, rather than how much space is left, right? So you don't think of the buffer as something you fill up to a certain point and then write. You just think about as, oh, what do I still have to write elsewhere, right? Because this is not the destination, right? This is just the temporary holding plot, because you cannot actually send it to the real thing.
Sure.
So in that case, if you think of that point, maybe you should rename the APIs like bytes, like byte the things we just had. I don't know how we would call them, but basically, I think if you think of it from a different point of view, you probably would write your API calls differently. Because bytes available, for example, is not the question you have. Right? Bytes available is just you expressing your policy of, oh, I need to write to the destination as a hint over how many bytes are available, right? But that's not necessarily the most natural way to think about this. It's more like, how, is there stuff left that I should write? Is the question you're really asking.
I don't see the reason why we can't have both objectives.
It's not both, it's just about the names, right? So for example, we already said we will have bytes available and bytes written, right? The question is just, if you're the consumer of the API and you write this outer loop that has to determine when to call, move to and move to async and flush on the stream, then our current model is that you're thinking in terms of, oh, I need to do this periodically, so use the how much my array buffer has been filled as a hint to when to do this. So that's why we use terms like bytes available in the buffer, right? But if you were to think of it from a point of view of like, oh, do I have everything? Do I have something to write? Now do it. You would call the APIs differently. You would say something like, how much data is there for me to write, for example? Should I write?
And that same thought that when advanced is called, because you don't have a big enough buffer, is it filled to the exact size you need, or is it allocated more? Because that would kind of affect how you want to, call flush or not call flush.
Advanced doesn't grow the buffer. You mean get span, get memory?
I'm assuming advanced did. What does it do then?
Advanced just tells the buffer writer how much you've actually written. You've already written some data, and you want to say I've written that's 100 bytes. That means you already had 100 bytes in the output buffer to write to.
But what if the user passes in a value that's larger than the buffer?
That throws.
Okay.
Yeah. You can't advance past the end of the buffer, and you only advance what you've written, which is you get this. The pattern is you get span, you call get span, you get a span to write into. Once you've written some data into it, you call advance to say I've written X amount of data, and that amount should definitely be less than what the get span returned to you, because otherwise how else would you end your writing?
Okay, for some reason I thought it was a global.
No, so what grows is calls to get span and get memory. So if get span and you give a size hint and you say 1 million, and it doesn't have 1 million, and it's feasible for it to grow to 1 million, it might give you something like 500K or 1 million. So this is why it's size hint. So it's not guaranteed to give you what, and that's the interface of the IBufferWriter. That's not necessarily part of this API, but I mean, this implements this, right? I'm just following it. Size hint gives you gives the underlying implementation a hint of how much the user requests, and you can give anything between greater than 0 and less than or equal to, or greater than even the size hint.
So I can ask for 5 and you can give me back 1 million.
Yes.
But if I ask for 5 and you give me back 2,
that's also possible.
That's also valid. You just can't give me back an empty buffer.
Yeah.
Wait. So
that's awesome.
You can say get span, and I want 5 because I have 5 bytes to write, and you can give me back one that's 2, and then it's going to fail.
Yes.
That seems bad.
Yes. So it's not minimum size, and that's how it's size hint. Mainly because in Cashew's usage, which is where this interface was initially designed, they require the ability to not have that strong contract. Which is, if you ask for 5, we have to give you 5.
Seems like there should be an option to say, I have, you know, this much data. I have to write this much data, so therefore I need a buffer this big.
Right.
Because
So-
otherwise, users are going to have to keep requesting again and again, and they're not going to have any escape hatch for, oh, I'm using a buffer writer,
Yeah.
and I actually have this much data. I have to write it once.
Problem is, what do you have in the pool, right? Like if you ask for 4K, right, you may have a 2K buffer in the pool right now.
Yeah.
So you would rather fill this and then ask again for 2K than to force the thing to allocate the 4K
Right,
buffer.
right. But that's why I said there should be an option saying,
That's more of a conversation around the IBufferWriter.
Yeah, I think in practice you will never pass in sizes that you just said, right? It's not that you want to write an int and you ask for 4, right? It's more you're very likely to ask for much larger sizes, in which case you're very unlikely to.
right, but that's also the case of like the user says I need like an 81K buffer because they know that's the performance metric for their stuff.
Right.
And you give them back something that contains 1K. I mean, they have no way to be able to say, I definitely want this. And on the flip side...
No, they do. Like, it just means you have to do your own pooling. Like, if you have super specific requirements of what you want, then you provide your own IBufferWriter implementation that does the pooling the way you want.
By the way,
well, that seems like the case from the get-go, definitely exposing the constructor that takes array pool.
So this thing will do what you ask it, right? Like if you say get span, give me 81K, it'll give you 81K. It's just that the interface does not require you to do so.
Okay.
Right. Like it's almost similar like to the read method on stream, right? You say read, give me 2K, I give you a 2K buffer, and then the thing gives you back 100, but it's not done yet.
Right.
It's just because the 100 was just conveniently available in memory already, so they didn't want to block, right?
Exactly.
So that's similar as in like it might be inconvenient for the caller, but I think the problem in general is when you write your code, you have to handle the fact that you're writing more than what the memory currently has, regardless of whether you passed in a larger size. So like the contract, I think in practice is not actually constrained on you, right? Like your normal loop will just handle that case just fine.
Right.
Is there, I guess on the flip side, if you have one particular case where you have to write like 81K, but then the rest of the time you have to write 4K, is there a way without disposing the buffer to be able to say, I want to shrink the backing pool? That way, overall goodness for the GC, and for being able to share that buffer with other people without having...
Basically, you're asking for fine-tune control of the size of the underlying buffer.
Well, not necessarily fine-tune in that case, but the ability to say, I no longer need something that's 81K, you can give it back, and give me something that is smaller.
Do you clear the entire buffer that you return?
I would assume that any such shrinking method would require that the user did copy to in the first place, meaning that bytes available is the entire length of the underlying buffer. Basically, put a requirement that the user has flushed it, but be able to say you can give this one back and give me a smaller thing from the array pool.
If there's a scenario or request for this feature, we definitely. I don't see any reason why not. It's just that the mechanism of how much data you're clearing and what you have to act as a precondition, like you make sure you flush everything already that you have. It needs to be solidified.
Yeah, because the scenario would be like, I'm writing a bunch of JSON data, and most of it's small, but then I've got one really big one.
Right.
And then now until you dispose, you're hogging a bunch of memory that you don't need to be hogging.
All right, so it seems like we're kind of done.
I had one question.
Okay.
Was around this output as memory, output as span. These APIs return what you've written so far as memory as span. So if you want to do something with it, I don't like the name. That's right. So basically, a view into the underlying buffer, which is from 0 to bytes written. Or length.
Span seems not problematic. Output memory might be more problematic because
the main reason, again, I think Christoph brought it up, but the main reason why we have output as memory is so that someone can call copy to async or flash async on the stream. They can take this output and write directly to the stream themselves. And stream async does not have a span-based overload.
Oh, because you have to write it to an async method, and the async method only takes memory.
That's right.
you do anything bad with it? And what I'm thinking about is this problem that we had with memory stream, right? When we leak the underlying array, like you can fuck yourself pretty badly.
But in this case, we're not leaking the underlying array. I mean, it could be, yeah.
You're just leaking effectively
the view into
the view over that, so that you still.
But it is read write, so.
It is read write, but at the same time.
We control the disposal. And
controlling it only to read would be weird too. So I don't know. Game by that.
Yeah.
I mean, you could write to the span, right, and then call advanced probably. So you can still make the scenario work if you really want to write to it.
No, because the span keeps growing. What do you mean? The span you have, you would not be able to write to it. That's if you're using the underlying writer.
No, but if I ask for output as span, I can totally write to that span using some API that takes span and then just advance 4, right? And then I've just written 4 bytes to your underlying buffer, right? That seems fine.
Oh, sure. Yeah. But I was saying, like, if you want to use some underlying writer to write data,
right?
And then you want to say, give me the data that you've written, so the entire thing. And I don't want to call copy. I'll do my own stuff.
Right.
So I need to pass this to a stream.
No, that makes sense. That's what I'm saying. I mean, like, in that sense, we could just constrain it to read-only span, read-only memory, right?
Oh, sure. Yeah.
All I'm saying is that it doesn't buy you much because you can still safely write to it, assuming you call advanced yourself, right? Which seems fine.
No, I would not write to it.
So in that case, why not make it read-only span, read-only memory?
Yeah, actually, I would define the data.
I mean, all I'm saying is that I don't see a reason why if you would disallow it. It's like, if you do it, sure, you just have to call advanced. But that's basically the way IBufferWriter works already, right?
No, because this is actually turning your view into what has already been written. If you're going to start writing to an advance, you have corrupted your data that you wrote.
Oh, because that's literally what I see what I'm saying.
Yeah.
It's not, yes. Yes, don't do that. Okay, make it read-only. Makes more sense.
How about the name? Fine with it, or?
I think I'll put as span, I'll put as memory. If it's read-only, yeah, it seems fine.
Okay.
I mean, the so far, I'm not sure, maybe that adds, maybe it doesn't. I think you say output, right? So it kind of implies that's what's there, right?
Should the outputs that have already been written be read-only? Because it implies that it would be incorrect to modify them at this point?
That's what he just.
Okay.
Yeah, I just said, like, it seems like you don't want this to be read-write because you literally write over the stuff you just wrote yourself.
For some reason, I thought that the Stream API took read-write memory. Can you confirm that?
So which one?
Stream.write.
Well,
I think you're right, but I think there's an unsafe cast you can do, right? Wasn't there?
Yeah,
What's the scenario for these two methods then? I mean, to view the data you've already written?
It's read-only. Sorry, what is it, Steve?
The scenario, I mean, what's the real world scenario for looking at the stuff you already wrote?
Yeah.
What is the scenario?
It's basically if you want to do your own version of copy to and copy to async, right?
also debugging.
Right. You want to know the underlying state of the.
Oh, okay. Yeah. Otherwise, when you call get memory and get span, the IBufferWriter, you're just getting the forward memory.
Get memory is the inverse of output as memory.
Right.
I had the same confusion in my head.
I think you would at least want to rename these in some way then.
Yes. So do you have a good suggestion for it, or a suggestion?
I don't know. Memory written, span written, or something. I don't know.
I was thinking.
I mean, bytes written as memory, bytes written as span. I mean, that's pretty much hard to confuse at this point.
Right. And now it's a very verbose name.
I have two really quick things. One, the class isn't sealed. I wasn't sure if it should be. And then the copy to async. I don't know what the deal with task versus value task is anymore. Is it a net standard thing or, I thought value task was recommended for perf, but
That's a good question. So let's start with the first one. So I think we concluded we don't want to call it copy to, or we want to call it something else that implies the move, right? Copy to should be.
Even with move, should we not consider adding clear to it, to the name, or some sort of thing that indicates that's also clearing?
copy to and clear.
I mean, to me, move. I mean, the only way I can think about a move is that you reset the other one, right? Like I don't know. I mean, I don't know how else it would work, but I think if we call it send or copy to, then yes, you need to include some sort of like, oh, by the way, the data will be gone from your source, right? I mean, I could live with clear and copy. Oh, sorry, copy and clear.
Okay.
And clear and copy would be bad, but copy and clear seems fine.
Copy to and copy to clear and clear async.
Copy and clear, and yeah, copy and clear async.
So we drop the two suffix here.
Maybe to keep it.
It seems like copy async and clear. I know it has to end with async, but the clear is not async. I don't know. It's kind of confusing.
Yeah, that one is one of those things that's like, I don't care. The convention is more important than the.
Yeah.
Because I mean, like, yeah, you can. I mean, if you think about it, you can't really construct a case where async would be sensible, so that seems fine. But the value task one is a good one. So should we make copy to async return value task of t value task? It seems like there's no downside to it, right?
So
like
when
the
task finishes synchronously, then it doesn't have to allocate.
Well, that, but also like you can do the new cheaper one if you wanted to, right? Where we do even the async operations in a cheaper way, right? With the whole, I forgot what Hope called it, but the new.
That's something you can put on my to do. I'll confirm it to Steven, and if he's fine with it, I'm fine with it. So the other thing was default argument on the constructor is no longer 256, it's -1.
Well, should we return?
And did you say the class should be sealed?
I think so. I don't see any reason why someone would want to.
Yeah. Okay.
Or.
Otherwise, I think the dispose has a pattern around that.
Correct. Yes. You need to have a
bool.
Virtual bool that takes a bool.
Yeah.
Okay, so see the type. What was the constructor one?
Initial capacity should be set to -1 at the default.
Yeah.
Rather than.
Or if we don't like, -1, then an overload that takes no parameters, and initial capacity is not default. Because I know there's been feedback before of -1 is a bad default value.
We could do 0 as a default value. I don't know if negative.
Yeah, that might also.
Where 0 means I don't care, just give me whatever.
Yeah.
So 0 is fine. Some sentinel to indicate.
Yeah, some sentinel that's not hard coded here, so we can change it in the future if needed.
Yeah, 0 probably makes sense too, because I don't want to introduce a negative value for in this case. Yeah.
I mean, honestly, at that point, just have 2 constructors.
One that doesn't have anything.
Yeah. And then just set the dynamic value.
Okay, that's fine. You don't have operation overload. No, the method constructor overload.
Because I think initial capacity of 0 would be pretty close to nonsensical, because why would you serve an empty buffer? Right? That makes no sense.
Yeah.
So -1 at least implies that clearly the size is not -1, so it's some other value, right?
Yeah.
But so 0 seems bad. I mean, personally, I don't buy the argument that default parameters need to be defaulted to default, because I mean the whole point of them is that they show up in IntelliSense, they show you what the value is. So if you don't want to default, it's fine.
Kind of just concerned about that.
Yeah.
We are making our internal implement detail public by saying 256. Or by
I completely buy that we don't want to leak the actual value, because then you can never change it.
Yeah.
I think in practice, though, you might find that you can never change it anyways, but that's a different problem. Because I mean, once 256 is widely used, and now you change it to 4K, you might regress perf left and right.
Well,
you may exhibit different race conditions, whatever. Right? Like that's just.
Well, we already have the case that 256 is guaranteed. At least in this case, to provide at least 256, but it could give you more. So there shouldn't be a problem with upping it because it's already the case that you may get more than what you asked for.
Yeah, I'm not saying like there's a violation of the contract. All I'm saying is that there is a problem in general when we mess with things like this, because it turns out that even though nobody have it as an explicit dependency on it, you change the flow of your code. Now you round trip multiple times, you allocate more memory, and that might be not what you want, right?
So one thing I wanted to talk about what Christoph left is how are we distributing this library, how are we shipping it? Because today,
I need to run.
If you were to put it in the system buffers assembly, which is where IBufferWriter in system memory or system buffers, wherever, then it would be inbox only. And one of the primary use cases here is a JSON writer which targets National 2.0. So what should we do around shipping so that it supports it? Christoph can use it.
So, I mean, this is the whole ooping discussion again. I mean, I don't know. To me, that's almost orthogonal to API design. Like I would, as I said, like my general rule of thumb is we start with assuming it's inbox, and then we figure out after the what would need to happen in order to ship it down level.
Okay.
So we put the type where we think it should be.
Yeah. So should this type live next to the interface IBufferWriter, i.e. in system memory, or should it live in system memory assembly, or should it live in system buffers?
Remind me again what the difference between the two is.
There's two separate assemblies. In terms of like system buffers contains array pool and sequence reader. Not sequence reader. Array pool, memory pool.
The system memory is the assembly where we ship span down level, right?
Yeah. System memory contains span, contains IBufferWriter. This interface IBufferWriter. It contains the release sequence.
And on core it's empty.
No. It contains APIs like it used to contain things like parser and formatter, and operation status, and a couple of other things that we may have started moving down as well.
But that's what I'm saying. I mean, like most of the types that used to be in there are type forwarded down, right? So like it should be.
Real sequence is not real sequence is still above, and all its extension methods.
Yeah, I think as soon as you have a partial facade on core, you're screwed. So if you really want to do, down level, then you want something that you can actually wrap.
But that we don't have anything
like that, right? Because I mean, the
buffers in box, system buffers in box, system memory in box. So they both are partial facades in some.
I think for framework it probably doesn't matter which one you put it in because they're both OOB. On core, the question is what do you care about. If you want to be OOB on .NET Core 2.0 or 2.1, then it matters because as soon as you have these partial facades, like you can no longer update them out of that.
My assumption is system memory and system buffers are both frozen, and they're both only being extended for 3.0 only.
I see.
So I'm actually looking for the typical place where this would go, not around OOBing or support.
Then I would just say I would put it close to wherever we put array buffer. Sorry,
array pool.
Array pool.
Not next to the interface.
Interface is lower supposedly, right? Or higher. If the interface is higher, then we cannot put it lower, right? If the interface is lower, then we can put it higher. I think all I'm saying is array pool seems to be low enough. That's all I'm saying.
Okay.
I don't think it needs to be lower than array pool. That's all I'm saying.
All right.
And in fact, you probably can't because you need to call into array pool.
Yes.
So
system buffers DLL then?
Seems fine to me.
You can put things in system buffer namespace inside.
We have no rule around that. Like namespaces are organizational and assemblies
do we
are.
have already a system buffer namespace within that?
Yes, I believe you do. I might be wrong, but. Oh my god.
Nope. It's just array pool lives in system buffers. Okay, that's fine. Anyone else have feedback or?
Well, there's like a fuck ton of comments since I looked last time, so I'm trying to read them now.
Yeah.
Right now they're just pontificating over Nick's use of EF or not use of EF.
All right.
Yeah.
What's up, Steve?
Oh, nothing.
Okay.
So Ben says it should be task, not value task.
Okay.
Because task to complete a task is faster than value task wrapping a task. I wouldn't wrap a task, right? It would just be the completed value task. But Yeah, the only reason why I said value task is not so much. I mean, you're not allocated in either case, right? Because you can always have a completed task because you don't have an actual T there, right? So you can always.
Oh, that's true.
But the thing is that the only reason why I said value task was because we now have an ability to complete asynchronous operations in a less allocated way. And so that was, I don't know how this relates to value task versus value task of T. Maybe the gains are only for value task of T, not for value task. But I thought it was also for value task cases where we complete asynchronously.
So when we added APIs around JSON document, they return task. They don't return value task. And we just added them now. So.
Well, did we explicitly decide this?
I believe so.
Because that might just be an oversight.
Oh, I see. Okay. So I'll just follow precedents, recent precedents at least.
Trevor was asking what pool. Well, the arrays you're allocating here are coming from the array pool, right? You're not newing up arrays yourself.
Yeah.
And then when you grow it, you just return the current one and you get a new one, right? So yeah.
I definitely agree with Christoph in that we do need features around stream writer. We need the buffer writer feature, or sequence writer, or whatever you want to call it.
For the stream case?
No, yeah, we need a stream writer that's directly writing to stream, so that it's more clear what it's doing. We need a buffer writer which actually implements IBufferWriter or takes IBufferWriter unless you don't have to. The user doesn't have to worry about advanced memory span because the interface is hard to deal with anyway.
So what will BufferWriter do?
BufferWriter will say, "Hey, you want to write an int? You tell me an int, I'll deal with the."
Oh, I mean an actual one that gives you like convenience overloads that are actually sensible to the thing you want to write, rather than here have a span and go party on it yourself.
Exactly.
So what happens when you need to grow the array to something absurd? Like you just stop using the array pool, or does the array pool handle the case when you ask for a 4 GB array? Do we not stuck with the 4 GB array?
It throws. We will not allocate more than 2 gigs.
Sorry, I'm just saying some absurd size. Let's say, I mean, do we actually pool arrays that are 2 gigs in size?
No, the pooling is based on 1 megabyte.
And so once you grow beyond that,
it automatically starts allocating. The array pool itself starts allocating.
So,
it's the same behavior as if the array pool itself was exhausted. In your current app, if your array pool user exhausted the pool, it'll start allocating anyway. Yeah,
Nick's concern was that because you're baked by an array pool and you write something absurdly large, you're now stuck with this thing forever. But you're saying, no, in that case, the pool just basically just allocates and allocates the thing effectively. Makes sense.
So just a question. If I call like get memory twice or whatever, get memory and get span combinations and pass them the same number, it's just going to keep returning me the same thing, right?
Yes.
And if I pass in something a little bigger, it's just going to blow up if I can't. It's too big. It's not going to re-allocate.
If you pass a size, if you try to ask for something too large, yeah, it will blow up, but otherwise, no.
Okay.
It's based on size int. If you just say get span without a size int, it'll just give you whatever it has, as long as it's large enough, and grow it.
What do you mean by grow it? I mean, it has a buffer under the hood that's maximum. It won't grow automatically, right? Based on another conversation.
So if you keep calling get span without a size hint, it will only grow up to a certain threshold and stop growing. Yes.
Okay. If I don't pass in any size hint, it's just going to give me everything.
No.
All right. If I zero.
It's not going to give you everything. It just gives you whatever sizes it has.
Oh, right. Okay. Well, that's what I meant.
Yeah.
Okay. So, I mean, that's a method. I know the other ones are properties. The output as memory ones, but I don't think it matters. But
well, the reason why get span, get memories are methods is because they would resize, which means they're expensive operations, and therefore they will not be properties. The output as memory and output as span are literally slices of the underlying buffer. So they are very fast operations. They're not doing any resizing. They're not doing any work. They're just giving you back a read-only view into what has already been written. Which is why they can do properties.
Okay, so every time you call get span or get buffer, you call it again, you might get back a different address, right?
Right.
So you shouldn't keep those around.
Yes. So the funny thing is, like, around having a copy to API, if a user passes to you a stream and they just say you deal with writing to it, you don't want to say I'm not going to write anything to it. You write to it. And here's I've written some data, but you write to it now.
Yeah, that seems a bit bad.
Because you're just writing JSON as an implementation detail from their perspective. And you say, I've not written anything, you just write.
Yeah, I see it now. I know you have an implementation of this already, so I'm just taking a look at that now.
Yeah. So one thing I'll do as follow-up is file issues around BufferWriter and StreamWriter.
Right.
At least to track them. I don't have a proposal for them yet, but
yeah. To Christop's point though, like, did we just completely drop the ball on this one?
Unlike the basically the point was that JSON reader, JSON writer would be the scenarios that drive the requirement on BufferWriter, BufferReader, and the JSON writer no longer required it, so therefore there was no strong scenario to push for it.
Because you directly use IBufferWriter.
Yes, sir.
Because you're a hacker.
And wanted to squeeze as much performance, yes. I didn't want to rely on abstraction.
I see. All right. So unless somebody else has a question, then I would call it a day. I wanted to do this for half an hour, but it seems like we were still pontificating over what we can do with this type. Then I think consider this type approved with the tons of feedback that I have.
Yeah.
And then we need to, I think as follow-up, we should just what happened to we should take another look at BufferReader.
Not reader. The reader is there. It's called sequence reader.
Sorry. At BufferWriter. We were hoping that the JSON APIs would drive requirements, but we end up bypassing it entirely. All right. Sounds good.
Awesome.
I will submit the notes and then we can move to more fun stuff next week. I think, next Tuesday. No, do we have something for Friday? No, Friday I cancel everything because we have our glorious all hands. Yeah. And then on Tuesday we have another 1 hour attempt at Levi's APIs, which last time we said we'll take an hour, and we took a full hour to just review half of the first one.
Yeah.
So we'll see how this goes.
Did we do GitHub triaging?
So that's the other thing. I want to do the triage next Tuesday, which is why I unfortunately had to decide that Levi's thing is still an hour.
Okay.
So we do 1 hour of triage, 1 hour of UTF-8 goodness, and then on Thursday next week, you'll look at pipe reader, pipe writer.
Adapters?
The stream adapters, and then I think the week after, we settled for Steve's JSON serializer. So,
okay.
Cool stuff.
Awesome. Thanks.
All right. Thanks, guys. Now I have to disconnect YouTube as well. Bye, folks.